Good morning to one and all present here. I'm Avinav.
I'm Yukta.
A very hearty welcome to you all to the 4th Foundation Day of this wonderful institution, IISER Tirupati. We are here to take you through the events of the day.
We are very privileged to welcome our chief guest for today's program, Padma Shri Professor S. Shivaram, Honorary Professor and INSA Senior Scientist, IISER Pune. Welcome, sir. We also welcome Dr. Rama Shivaram. Welcome, ma'am.
We at the same time extend this warm welcome to all the invited guests today. We also extend it to our own director, deans and chairs of all the disciplines, all our teachers and friends present here. We would like to start the program by presenting a glimpse of the journey IISER Tirupati has been through since its inception. Let us watch a video made by Fovia, the photography club of IISER Tirupati.
Achieved by bringing together young minds with a distinct inclination towards science. Achieving this would, in effect, enable them to make a difference to the society by inculcating the belief that the research carried out has implications on the society, and hence, the society too should influence the research. Let us now hear from the director and the respective head of departments at IISER Tirupati about their views and opinions on the rapidly growing science environment on campus.
Greetings to you all on the 4th Foundation Day of the Institute, IISER Tirupati. This is a day on which we remember past achievements and also set up goals for the future. During the past year, we have close to 250 students who have joined the Institute, and we also started doing PhD and PhD. We also had several new faculty who have joined, and we have 3 senior professors, Professor Vijay in biology, Professor Adhika in physics, and also Professor Nagaraj mathematics have joined as a field. So they helped us in mentoring our faculty. We also have seen a progress in the campus construction. The most important thing was PPR, or Institute, approved by Cabinet, and this is very great for starting the campus construction. We've already started 2 new hospitals, also an undergraduate campus. The research is taking a good shape in IISER Tirupati. We have established lots of laboratories and also advanced instrument facilities like electromagnetic resonance, mass spectroscopy, conformal spectroscopy, etc. In chemistry, the research focuses on bioorganic chemistry, chemical biology, particularly about protein acid interactions, spectroscopy, semiconductor fundamentals, material science, particularly the area of energy. We also have research going on use of mass spectroscopy for detection of cancer, and also in the area of bioinorganic chemistry, looking at mechanisms in science. So we have a very diverse area of research and chemistry. We also had several distinguished visitors visiting IISER Tirupati on various occasions in Colombia, seminars, etc. And in the past year, we also had international symposium at IISER Tirupati. So with these things, IISER Tirupati in a short time has come into full, and we look forward to further progress in the next year. And this campus will also upgrade some students' facilities, although it's constraints between sports, but I hope students are really enjoying the campus. We do look forward to the next year when we should move towards the campus. I wish you all a very happy foundation.
The discipline of the disciplinary circle is getting formalized in a balanced structure. Almost all areas in the content of research need that. We give equal importance to teaching the basic courses in physics also. The courses offered in physics form part of a IISER program here, as well as the history programs. These courses are designed to train the students in understanding the laws of nature, in the private knowledge of so we ensure that the training that we give students will help them to career in these activities for related areas of applied science and technology. With this, our strengths are basically astrophysics and galactic dynamics, experimental energy physics, critical currents matter, soft matter, lasers are optics, atomic and molecular physics, and molecular dynamics of systems. We have established research labs in soft matter and atomic and molecular physics, and the optoelectronics lab and another for antimatter are being set up. Our research publications are also increasing. In the current year, we have already gone up to 25. From our software lab, we have a recent paper on spreading of droplets on powder surfaces published in this review. The hydrogen disease group have an order on particle production in radioactive conditions, while the astronomy astrology group has published papers on star formation, Nova's vortex, and structural dynamics of these galaxies. These are published in monthly notices of the Society and Astrophysical Journal. The theoretical concept group is very active. Recently, they have a paper in physical review where some unequal lattice. And the monitor dynamics we have publications in four recurrents and level index defects, as well as publications related to dynamic systems, which can be collected between slow and fast diagrams, and the concept of data networks and later levels of data analysis. So the last 1 year, we have prepared the weekly seminar program agency, with one seminar happening every week. Since August 2018, we have completed 20 seminars like that. These seminars are delivered by faculty from outside as well as non-faculty, and they are well attended by both students and research students. And these have helped our students get an understanding about the recent trends in research in these areas of focus. And in fact, we organized a physics day in January this year. This was a one-day event where our faculty gave talks in their latest research, and each research group presented a poster. This was well attended by faculty and students, led by students also. And because of the IIT Tirupati, we are planning to establish a center for atomic, molecular, and optical science and technology. And the focus of this research will be mainly on electrical physics, quantum science of confined systems, laboratory astrophysics and astrophysics, hybrid charge diagrams and plasma physics, biophysics, using particle fuses, and quantum physics, etc. So the preliminary discussions on this are already done, and we are hoping to establish this center within a year. So in short, I look forward to the exciting and active time center in the current year.
Another thing about IISER is well set. It has very interesting programs for young researchers to come and join. We have faculty members who look at biology at various scales. scales from organismal to ecological to cellular and other aspects. Most of the biological research dwells in the mechanisms of how cellular functions achieve complicated regulation in relation to function. In addition to research, the program has heavy emphasis on food undergraduate teaching, starting from basics of biology to the regulation in biology to various advanced topics. And our teaching encompasses several courses in undergraduate syllabi that benefits large number of undergraduate students in IISER Tirupati. We have recently introduced integrated PhD program as well. First class has joined us. We have recently good number of postdoctoral fellows now in the department. We hope to increase the postdoctoral fellows strength to a higher number. And at the end of the day, by setting up a biology program that is highly interdisciplinary, we want to reach out to other areas of science such that we understand biology in the context of not only descriptive biology, but also in terms of how biological logic evolves, utilizing chemistry, physics, and mathematics as the mechanistic processes. Mathematics in IISER Tirupati, we are having an academy, all of which I am the oldest person, and all of us are young people. And the areas in which the academy works are analysis, probably we can say that analysis, algebra, topology, differential equations, and number and algebra. So these are the main areas of the faculty, and we also I think mathematics is a subject where if you like it, you will always want to do mathematics. So we encourage to do that to all the students who have come to us for asking for their difficulties. And I think it's a next. We also in the first 2 years, the mathematics department also get us for the other department and the departments people. There will be some lectures to be there. And the other next 3 years, we also give specialized courses. And research wise, there is analysis, algebra, these are the main areas of research.
IISER has provided its students with a platform to kindle new interests and acquire new skills. Breaking generic trends where the focus is confined to academics, the belief system at place here nurtures every aspect of a strong personality and not just as a research scholar. To facilitate this, the Institute has been very supportive in promoting a myriad of co-curricular and extracurricular activities. Despite having its current base at a transit campus, the students have never faced any lack of facilities. Of course, things are only going to get better in the future. With the establishment of the permanent campus, IISER Tirupati would definitely emerge to include everything it isn't at present. While it is a common perception that sky's the limit, we here at IISER Tirupati allow the limit to tend to infinity owing to its defining motto. It was indeed an incredible video. Hope you all enjoyed it as well. Now, we invite Professor Ganesh to present the annual report of the Institute and to introduce the chief guest.
Good morning, everyone, and I have great pleasure in inviting all of you for this 4th Foundation Day function of IISER Tirupati. A special welcome to today's chief guest, Dr. Shivram, and also Dr. Rama Shivram, who will be giving us lecture in the afternoon. I'm sure all of you have seen the announcement. And also to all my colleagues, faculty, and students. Now, every institute assigns a day, as an important day in the year. You call it annual day, institute day, foundation day. It is a day on which we just remember our origin and also how we have progressed. So at IISER Tirupati, we have called it as the Foundation Day. It was in March 28, 2015 that the foundation stone of IISER Tirupati was unveiled. And all of you, I think, near our lift entrance in the ground floor, you see a big plaque. And that was unveiled on March 28, 2015. So this is just a glimpse from that day, and I don't think I have to really tell you who are the people on in the picture. And all I want to tell you was that was a day on which it was a very hot, March. It was very hot, and we had you would imagine we had about 50,000 people gathered on our campus. The way IISER Tirupati is going to be established. We had already had the land. And 50,000 was the audience, and we had ministers announcing the establishment of 3 institutes, not just IISER Tirupati, IIT Tirupati, and also IIIT. So 3 foundation stones were unveiled on that day in the midst of about 50,000. So I was lucky. I also could address. I thought almost I'm addressing election rallies. 50,000 people, and so that was the day. So, keeping this thing, and every end of March, we celebrate our Foundation Day. And sometimes, 1 or 2 weeks off happens depending upon the chief guests and also our own convenience. So, this is the unveiling of the foundation stone. Let me also tell you, this is the stone, and here you see 2 of my colleagues, and some of you have met Rajshekar, who is the registrar, even now currently is the mentor registrar of IISER Tirupati, and Dr. Srinivas Kota, who actually led the establishment of the different disciplines. We had 3 other colleagues, but he had taken a major lead from IISER Pune in establishing the team for the IISER Tirupati. So this is the foundation stone. This is just a lot of you have joined since then. You will be knowing what happened about 4 years back. And this is how the campus is, the land which is given. There is a highway here, and our campus land is situated across the highway. A big chunk of land on this side and a small chunk of land, about 75 acres. And here this is about 150 acres. And we also have 2, water bodies. Sometimes if you imagine that there is water there, summer and evaporate, they are real water bodies. Sometimes you will see water. And at this point, I must remember what Dr. Shivram did when we established IISER Pune. The first thing he did was to put a chief of NCL colleagues to establish IISER Pune. So I took a leaf out of that, and I had this experience. So when I was asked to be the mentor director of IISER Tirupati, I put a team of people from IISER Pune, and many of them have, all these people did a great job in the very first year in establishing today whatever we are enjoying, whether it is academic structure or the infrastructure, etc. They have played a great role. So I think I would like to remember and thank them for giving me all the help for the establishment of IISER Tirupati. And I'm sure you will recognize some names. Dr. Nathu, who was my senior colleague, and Mr. Rajput, who was the engineer, who really took a burden of establishing all the laboratories within a record time of about 3 to 5 months in this building. Dr. V.S. Ross, some of you already met him, he took a major administrative thing, and Dr. Bas Bapat was the dean. So I must remember, these people, because giving us today whatever we are enjoying, it is because of the foundation that they laid in the beginning here. And we had on the 10th of August 2015 was the day on which our academic session started. We had the first batch of 45 students who joined here, and this was the then Secretary MHRD addressed. All the students and the parents were gathered, and this is in the so-called Ramanujan Hall. And you see that already we were very well set up, even on the very first day, with all the infrastructure. And Professor Vijayalakshmi Ravindranath gave the inaugural talk, and some of the faculty who are here today, they were also present on that day. This was the first batch of students. I'm sure, I hope most of them are here still. Thank you. Yeah, and this is the first batch of students who joined in 2015 and who will graduate in 2020, along with the faculty who had joined them. I think some of them have become younger, some of them have become older, have become aged since that time, but we have, I think I'm sure you recognize the faculty. This is the first batch of students who joined at that time. The very first day we had this photo wrap. And we also had, at the end of the year, the so-called administration, non-teaching staff, and also the faculty, whatever. So this is just of historic importance that, where we made our beginning. So here today we are celebrating our 4th Foundation Day, and 2015, August we started. So in a way, we have just completed 3.5 years of our academic life here. And you will see that within the 3.5 years, we have done quite a lot of things, both on the campus here, transit campus, and also in our permanent campus. And this is our 4th Foundation Day, and the very first Foundation Day in 2016, our chief guest was Professor D. Balasubramaniam, a well-known biophysicist, chemist, science popular. He writes a lot of popular articles. I'm sure those of you who read Hindu, speaking of science, he writes articles there. And he's now an expert in medical biology, particularly talking about the eye. In fact, he actually brought an eye and dissected it. And a very popular talk, he gave in the very first Foundation Day, 2016. In 2017, we had Professor Deepankar Chatterjee, a distinguished biophysicist and a biochemist from IISER Bangalore. He talked to us about how antibiotic resistance is developed. A wonderful teaching talk he gave in 2017. In 2018, we had Professor Ajay Su, a very distinguished physicist. He came and talked to us on his work on carbon nanotubes, etc. So we have been going from one area to another area. And this year, it was the chemistry year. So we are very fortunate to have Dr. S. Shivaram. Later on, I'll be introducing him, a distinguished chemist, to address us on this day. With this very brief, you can call it welcome or whatever introduction. Now I'll try to tell you about, which is the convention, to recall whatever has happened during the last year, 2018-19 academic year, which we call as the Director's Report. It's always good on Foundation Day to share with public and the students the progress which our institute has made in the last year. Now today our strength of student strength is about 460 or something like that, and we started the campus with the first batch of 45 students and 10 faculty, and today we have about 468 students. So it's about within 3.5 years we have gone up by 10 times, 468 students, and the number has gone up 10 times, out of which 346 are the BSMS students spread over 4 years, and we have 68 PhD students, 22 integrated PhD students, and 25 postdocs. I think by any standards, I think we are doing much better than I can always compare with IISER Pune. I think the numbers are much bigger. We have made a very fast progress in the 3.5 years because we had the infrastructure and we had the experience to set up those things. The faculty strength is about 50. Normally, we are given a 1:10 ratio with respect to students. We already have 50, out of which about 20 have joined in the last 6 to 8 months. In the area of physics, chemistry, biology, maths, and climate science, and we have been very fortunate to attract distinguished professors to head each of the disciplines. Again, during the last year, about joined. And Professor Ambika, as all of you know, she's the chair of physics and who's also dean of academics, who comes to us from IISER Pune, where she did excellent background work for establishing, in her own research, non-linear dynamics. She is a very prolific publisher. And in addition, she also established from scratch what we call the student academic module. All of you call it SAM. In fact, that took its birth in IISER Pune with her expertise. She actually guided the software people how to establish this. And now that has led to what's called the GSAM for PhD and postdoctoral student. So very fortunate to have her here, again, guiding our student administration modules. Professor Vijay Rao joined us last year, very distinguished biologist who works in genome dynamics and cellular adaptations. and he has joined as chair biology. Professor D.S. Nagaraj come to us from the Math Science Institute. He's the chair of mathematics, and he's very well known in the area of algebraic geometry and vector calculus. And so this has been excellent development in the last year that I got 3 excellent colleagues who have now taken over completely in all the academic programs, etc., so that I can concentrate more on the administration. And also there be the senior presence of senior faculty is important to guide and mentor the faculty, and they are doing an excellent job. At this point, I'm very glad to inform you that Dr. Vijay Mohanan, an electrochemist par excellence in the country, and who was also my colleague at NCR Pune, and later became the director of Central Electrochemical Research Center at CSI Laboratory at Karaikudi, and he will be joining us next month as professor and chair of chemistry. And being an expert in the area of energy and batteries, his joining will be a very fantastic thing for us, because as you know, Tirupati has one of the leading battery manufacturers, Amar Raja. I'm sure all of you see the buses going. They make these Amron batteries, which is found in 60% of Indian battery production happens in the city. And with Dr. Vijay Mohan joining a battery and energy expert, and along with this industry, and also with IIT Tirupati, we are going to establish a center for energy. And so it's a very, very nice thing that Vijay Mohan is joining here. We have today about 35 non-teaching staff with 2 assistant registrars. All of you know, one for academics, Mr. Chaman Mehta, and the other who takes for administration purchase, Mr. Indrajit Singh Kohli, and we also have deputy registrar in finance. And also, I'm happy to inform you that we have just appointed the registrar of the institute. He is Mr. Mohan Kumar, who comes to us with a tremendous experience. He was a deputy registrar finance at Institute of Science, Bangalore. Later on, he was registrar at Central University, Hyderabad, and now he's the registrar at Tata Institute of Social Science. He comes to us with tremendous experience, and so we are very lucky to attract such experienced people, both in administration as well as in faculty. Now, this transit campus, which we started, we are spreading about 10,000 square meters, and a possible capacity about 500. All of you are staying there, again 10,000 square meters. We have also recently moved our guest house to our own hostel here. We have about 8 guest rooms, and in this building we have all our BSc, MS classrooms, teaching and research laboratories, library, faculty, and administration offices. They're all located. I must tell you that we are now seriously short of space, both for the new faculty who are going to join the teaching labs. And so it's very, very important for us to start planning and move to our main campus. So later on I will tell you what progress has happened during that. Now, coming to the academic activities, the year 2018-19 has seen increased academic activities, and due to time constraints, I'm only summarizing some of the most important ones. I might be missing some of them. So with the addition of about 20 new faculty, now we have started offering new courses. And this year's highlight is a course on forensic science, which is being offered in collaboration with NTU, Professor Richard Bates. He's administering the course. And I must say that none of the other IISERs have this thing. I always ask this question, what is that IISERs are doing which others are not doing? And we are not teaching conventional courses. So as a new initiative, we have started this forensic science, for which several people had approached me that, I will not say that, I should say it is a good thing. Crimes are increasing, so we need proper people to analyze scientifically. So, and it's also a highly interdisciplinary area. It has got you get a lot of sensors are necessary. Chemistry is there, biology is there. It's not that forensic science is not just chemistry. Nowadays, modern genomic techniques are available. It's a highly interdisciplinary science, and so we're very happy that we have run this course. And depending upon I think about 25 students have registered. And it also provides probably a good career opportunities later on. And we'll probably develop into a postgraduate course if that works out. Similarly, we have ideas to start new courses in things like data science, industrial chemistry, etc. Which are also used apart from the basic science courses. They will also open up new career opportunities for students. We will do that in the coming years. And physics discipline, they celebrated Physics Day 2019. At the participation of physics faculty at IISER Tirupati, and on January 6th, Professor Anil Kumar from University of Science was the main speaker, along with some presentations by physics faculty and students. It's very, very important that our own faculty come and tell our students and also other faculty what are their research areas, and each discipline are organizing this kind of days in which they highlight their current research interests and achievements. An important thing happened in physics area was also a discussion meeting on generating proposal to establish a joint center between IISER and IIT in the area of atomic molecular physics and optical science and technology. We had a meeting on 20th March, which was attended by the directors of IIT, IISER Tirupati, and also several other experts in the area. The idea is to establish, based on our own faculty strength, a modern center in atomic and molecular physics, optical science and technology, which leads to a lot of quantum technologies, etc. Hybrid quantum networks, laboratory of astrophysics, biophysics, plasma physics, ultrafast physics, etc. And we are going to generate a new proposal in which both the institute will invest and also will seek some external funding. This would be one of the very first IIT IISER joint proposals. So Tirupati is the only city in which there is an IIT and IISER. So we have decided jointly that we must initiate lots of activities to take advantage of our presence and get into areas where both engineering and science play a very important role. So we have several things we have planned out, and our campus will be, of course, the permanent campus about 2 kilometers apart, and we have plenty of interactions, including joint courses. So we don't have to repeat our courses, and our science students will get an exposure to the basic engineering courses and vice versa. The institute also has entered into a non-proprietary use agreement with Brookhaven National Laboratory in New York, which is within September 21st, and which allows experimental high-energy colleagues in our faculty here at IISER Tirupati to participate in data tracking, analysis, and participation in the STAR, experimental STAR collaboration. In chemistry, an international conference was held on the interface of chemistry, biology, physics interface, May 24 to 26, 2018. About 150 participants from abroad and India participated, and the outcome was an experience to see how to encounter challenging problems and how to solve them at that interface between chemistry, physics, and biology. That was also our second international conference, and that has been a great experience that even in this limited facility, we could attract international participants and hold international conferences. Mathematics faculty organized a number 3 seminar on December 2018, which is an initiative of mathematicians from IMSC, CMI, IIT Madras, and IISER Tirupati. This is another unique thing, it's not just IISER Tirupati, we have to go along with other institutions, take the experience, collaborate with them, and already many of our disciplines are doing that, and mathematics, exceptionally did this joint seminar. The area of earth and climate science, our faculty were very limited. We have just 2 faculty. Even then, they have been able to make some advances. They have put a modern laser hydrometer which measures the drop size distribution. One of the areas is to collect rainfall data and predict it all over the country, and they already have a premier position in this area. In addition to that, we also have research laboratories being established in petrology and geology. In biology, Dr. Robin organized a collaborative international workshop on bioacoustics with Cornell University, and it's a new area, bioacoustics. Sounds produced by biospecies, animals, insects, birds, whatever, in the larger context. And Cornell University has a very premier research contribution, and with their collaboration, this workshop was organized in 2 batches, about 25 students. And several students from IISER Mohali, Bhopal, IISER Calcutta, and IISER, they participated here. And apart from other research universities, this was the first such event in India in this area of bioacoustics. And the students' workshop was conducted in collaboration with this world leader in this field. And students also observed about 150 different species around the Mangalam campus. This was followed by a next generation sequencing workshop for phylogenetic analysis, which was conducted by Dr. Nandini, faculty, biology, collaboration with faculty from IISER Bhopal. It was attended by several PhD students across India. The institute is also supporting participation of our undergraduate students for the first time in International Genetically Engineered Machine. It's called as IGEM. This project started long time back at MIT in Boston, where students are trying at a very early how to produce a genetically engineer, the so-called machines, which are sort of artificial cells. Not only they carry out the cells along with the regulatory aspects, etc. And I think we have just entered the competition, and that was thanked our biology faculty and also the students who are getting into this very competitive things. They have submitted a project, they have registered. Hopefully, they will get an entry to that, and there will be a very good international experience for our students in this area. Mathematics department also attracted several distinguished mathematicians for lectures, discussion with the institute. Just to name, Mr. Raghuram came recently and gave fantastic talk and interacted with the institute. Other events were the institute organized, the IUPAC breakfast meet. IUPAC stands for International Period Applied Chemistry, and they had a very big meeting in Paris in this so-called International Year of Periodic Table. And one of the topics they want to discuss about celebrate the role and contributions of women in science. And during one of the meetings, our institute faculty also took part in the breakfast meeting in the team. As part of Women's Day activity, we had a lecture, an excellent lecture. I think all of you remember, Dr. Shanta from Cancer Chennai, an excellent talk on current status of cancer diagnosis and therapy. Institute also celebrated Science Day with periodic table as a theme on the eve of this International Year of Periodic Table. That's in just about some of the activities that is happening. Some of our faculty have found recognitions. I will just name 2 or 3. I'm not sure, to be honest, I'm not having all the other recognitions, but they are putting Dr. Robin. He received the National Geographic Explorer grant, a very prestigious grant from National Geographic magazine, if you know. And with that grant, he could conduct this workshop. And Dr. Vasudha-Rani Devanathan was named as the DAD Research Ambassador in Germany for a period of 4 years. She has been already in the forefront in establishing good connection between international organizations in India and particularly in Germany, where she herself had studied there. So she has been named as the DAD Research Ambassador. And Dr. Balaraman very recently received from chemistry Avra Young Scientist Award 2018. So it's being issued by IISER Hyderabad in honor of one of their very distinguished directors, Dr. A.D. Ramrao. So congratulations to all the faculty on receiving. Institute research has started just about 2 years back in an established laboratory. Faculty have to join, we have to hire PhD students, etc. Even with all this constraint, and I'm happy to tell you in the calendar year, about 45 publications have resulted from either work done or work written up in this institute. I think we have on the website details of all these things, and I'm sure this will pick up in times to come. And Institute also has created new advanced facilities, like NMR, 400 megahertz NMR, sort of pictures, hospital facilities, particularly for research in proteomics and cancer detection. We have ITC, high performance computer, and several new microscopic facilities. And with the new faculty joining, more such high-ended facilities will be created. Our only constraint is space and not money. Research projects, again, our faculty have been having joined. They have been applying to different agencies, and about more than 10 to 15 projects have been sanctioned. It's very, very important that we also write proposals and seek assistance from other grant-giving agencies. Coming to students' activities, students are very, very dynamic. As I said, we have close to 450 students here. And one of the event is the Inter-IISER Sports Meet, along with all the other IISERs and NICERs. It's a very important event which happens every year. In December 2018, it happened. And our IISER students, they got the first place in the march past. They got a third place in the football men. In track and field events, they got 5 gold, 3 silver, and 5 bronze medals. It's a very commendable achievement. And they also did very well. Incredible performance in the cultural meet, Inter-IISER cultural meet, and they also celebrated our own cultural festival. We won it at the Institute in January 2019. I must also mention the IISER Tirupati team, qualified for the finals of a very, very tough intercollegiate science quiz competition called Mimamsa, which was started by Sir Keynote. Very tough competition. So our team, having 4 members, they got into the finals. This was the first entry. I'm sure they come with good experience, and I'm sure of great appreciation for them. And next time, I'm sure IISER Tirupati will make it to the top there also. And students have also been very active in other programs like science outreach, women program, etc. And we have also established an Institute for Innovation Council Institute to promote innovation among students. We have just established it, and we will announce some programs so that the students will get into the so-called innovation trend, which is very, very important these days. Institute actively organizes various colloquia, invites distinguished scientists in different areas of science branches. During 2018-19, about 17 such colloquia have been held, and some of the speakers include Professor Roop Malik, Professor Raghuram, Professor Vedadar Mishra, Professor Ram Shesha, Professor Dayamaitra, Pradeep from Madras, Professor Venkatratnam, geologist from here, and Professor Dasibar Balsaris, Professor Satyamurthy, Professor Ashok Ganguly, and just about 3 days back we had Professor Jaikandan coming, and also Professor Umaram in different areas. And they come and give lectures, more appealing to a general audience about exciting about research in their own areas. In addition, we also have several regular research seminars given by external as our own faculty almost every week. The institute has also signed MOUs because we have to have a link with other institutions, and we have signed MOU with the SRM University for exchange of students, and particularly for use of their animal house facilities. We have signed MOU recently with Amar Raja Batteries here for cooperation in the area of energy and battery technology, particularly new materials, designs, etc. And students can do projects. And with the joining of Dr. Vijay Mohan in May, this will be very much strengthened when we have the Center for Energy Science and Technology. We also signed a MOU with the Institute of Molecular Medicine at National Chung Kung University in Taiwan for joint academic activities, including exchange of students, faculty, and research. Their team visited here, and we'll be visiting them very soon to talk out more details about the possible collaborative projects. They have some strengths in modern biology, and hopefully it will help us. We also signed an MOU for research collaboration, particularly in the area of medical sciences, with Sri Venkateswara Institute of Medical Science, SWIMS. And Institute, along with Sri Venkateswara University, is discussing with University of Melbourne on initiating a joint science program, which will give you a degree which is called the Blended Science, BSc Blended degree. So as you see, we are being locally relevant. We would like to sort of join the local institutions in Tirupati and also bring the flavor of international collaboration into Tirupati. Now, lastly, about the campus progress. The most important thing which happened in the last year, in September 2018, was the approval by cabinet for establishment of permanent campus on our land, and also funding for our equipment and furnishing, ICT, etc. And we have been given a total budget of about 1,490 crores, 1,490 crores for a 7-year period. And this funding will all come from a source called HIFA from the bank. So we have to take loan from the bank, but we don't have to repay the loan. The government will repay. It will happen someday, like farmers, loan will go off. But anyway, and this is the new government policy. It doesn't make a difference for us. We'll get money. In fact, we'll get money much faster because the bank is ready to just, likes to give loan to people. And in addition, the master plan for the campus, I think I've shared with you, most of you have seen the short video. Our architect is ADCOM Associates, who have done the campus at IIT Hyderabad, IIT Roper, and several other education institutions. They have done our master plan campus. It has all been approved by our board of governors. And you already saw some pictures. 2 blocks of the first 2 hostels of a total capacity of 480 is already started. As you see, it's on ground plus 4. I think it's already the structure is in place, and we hope that by August or even latest by December, this will be ready for us, and some part of our academic activity can be shifted to the campus. So having only hostels is not a solution because they have to come here for academic event. So what we've done is we've already started building an undergraduate teaching lab there, and probably in about a week's time the order will be issued. It's a 3,000 square meters, undergraduate labs in physics, chemistry, biology, a lecture hall of 200 capacity, several tutorial rooms, etc. The idea is that we should be able to carry out some of our, at least the first 2 years, activity from next year on the campus. And meanwhile, the other campus planning will start, and hopefully in about 3 years, the campus will be finished. Construction will be finished. That's our plan. So we have now finalized all the details of the main academic building. It's a very big exercise because we have to do everything in one go. We can't do it in parts and bits and pieces. So we need to design everything, particularly the laboratory designs are very, very intricate. Physics, chemistry, biology laboratories. Not only for the existing faculty, we also have to design for the future faculty who's going to join. We do not know what kind of areas, but we need to design the labs for them. And I think I was thanking a lot of my colleagues, faculty on these areas for spending their time in designing the labs, complete labs in classrooms, etc., etc. Hopefully by end of April or the middle of May, these designs will be completed, and then we'll start the process through architect and CPWD will just simply monitor the project, but not built by them. That's what we mean. CPWD will not build, they will only monitor the project. The building will be done. In case somebody has some question marks. So, and on this thing, today I'm very happy to announce that today we'll be inaugurating the first science building, a tiny building on the campus. It's a 2,000 square feet building, and this is for plant science and engineering research. So this because we want to start activities, and we had a building, and we also consigned space here. So I convinced my plant science faculty that they can actually start moving there. And the plant science people moving there is good for our campus. They will start not only do the research, also help us in developing greenery there. That's another selfish motivation. So today in the afternoon at 5 o'clock, we'll be inaugurating that. But because of logistic reasons, we'll not be able to transport all of you. You will always get a chance to visit that. And so I invite all our faculty today, those who would like to come, I request you to come to go to the campus. There will be a bus arranged, just one bus. And if you'd like to use the bus, or some of you would like to drive, you can drive. So at about 5 o'clock, that will be done. And I'm requesting our chief guest today, Dr. Shivram, to cut the tapes to the building. And once that is done, hopefully in a couple of months, we'll be able to put in all the equipment and the plant science research, because there will be active faculty going. So in the interest of time, many other events are missed out from this report. And at this stage, I want to thank all the students, PhD students, BSMS, PhD students, faculty and staff for all your sincere contribution and understanding, in spite of all the constraints what we are going through, for your contribution to the growth of the institute. And my sincere gratitude to all the external members of various committees, which include selection committees. We have appointed so many faculty, non-teaching staff. So for every one selection, whether we select 1 person or 10 person, we have to have a process. And I have to thank all the selection committee, particularly because they have given us very, very good people, whether it is faculty or non-teaching staff. They have been able to get good people, and they all joined us. So I have to thank the selection committee for that. And also I need to acknowledge the members of all of our statutory committees, such as Senate, Building Bus Committee, Finance Committee, Board of Governors, and also MHRD for their constant support. I should also thank and distinguish the government of Andhra Pradesh and the district collector Chittoor for all the assistance in facilitating several local administrative support for the campus establishment. And finally, I thank you all for coming to this function and wish you all a very happy foundation. So now it's my pleasure and privilege to introduce today's chief guest, one who is with us on the Foundation Day. Dr. Swaminathan Shivaram. And I have already circulated, his brief CV or invitation letter, so I will not go through the whole thing. All I would like to say is that he got his MSc Chemistry from IIT Kanpur, and he did his PhD from Purdue University with Professor Brown. And after 15 years of scientific research and managerial experience, he also had a postdoctoral experience in Netherlands, I think. Right? Yeah. Sorry, something was missing. I just remember. And further to that, he came back and he was at IISER, where for about almost close to 15 years, he had scientific research and managerial experience at IISER Baroda. And later on, he moved to NCL Pune as head polymer chemistry division. And he was appointed as director in CSIR NCL in 2002, and he completed his term in 2010. He was CSIR Bhatnagar Fellow at JC Bose National Fellow at CSIR NCL during 2010 and 16. At present, he is honorary professor in INSA Senior Scientist at IISER Pune. And during his distinguished professional career, he has published more than 225 research papers. He has trained more than 40 PhD students, 20 for the master's degree, and 50 postdoctoral fellows have been mentored. He has mentored, and he has received citation as inventor. It's an amazing thing for about 50 United States patents and 52 Indian patents. I don't think you will find, the patents, US patent. He is well known for his innovative research in synthetic polymer chemistry, especially polycarbonates, functional polymers, porous polymers, and polymers from renewable resources, etc. Dr. Shivaram has successfully balanced his basic research with technology development, transfer and patent licensing during his professional career, which is very distinctive and unique because he began in industry from where he moved to a national laboratory and finally to a university setup in IISER. Many of the products that were developed under his leadership are currently in the market. He is a much sought after consultant to chemical industry in India and abroad. He is widely respected both in academia and industry for his contributions and has successfully studied both the words with a great finesse. In view of his rich experience in applied polymer chemistry, he is on scientific advisory boards of several industries, important ones being Biome Therapeutics Limited, New Delhi, Apollo Tiles Limited, Gurgaon, Asian Paints, Mumbai, HLL Lifecare Limited, Thiruvananthapuram, and Hindustan Petroleum Corporation, Bangalore. He is a consultant to TCG Life Sciences Limited, Haldia Petrochemicals Limited, Calcutta, Aquaform, Pune. He is a mentor to several R&D setup companies and institutions such as Venture Center at NCL, Innovation Park, which is an incubation center, and Research Innovation and Scientific Entrepreneurship Prize Foundation of IISER Calcutta. He has received innumerable distinction awards. He is a Related Fellow of Indian Academy of Sciences, Bangalore, Indian National Science Academy, New Delhi, Indian National Science Academy of Engineering. One of the very few people who has been recognized by both science and engineering academies, and also elected Fellow of the World Academy of Sciences, Trieste. He has also been a visiting professor at several international universities in Europe, USA, and Japan. He has received innumerable recognitions and awards, important ones being Gold Medal, Lifetime Achievement Award in Chemical Sciences from CRSI, International Award Society in Polymer Science Japan in 2017, Distinguished Material Scientist of the Year Awards for Materials Research Society of India in 2011, and Honorary Doctor of Science, Purdue University, very, very prestigious, in 2010. He has been honored with Padma Shri Award by the President of India in 2016. Now, with this formal introduction, I just want to spend about a couple of minutes telling my own personal connections with him. And when he was at IISER Baroda and when he just got back from abroad, I almost, joined his group at Baroda, but I was interested, in getting into biology, so I joined CCMB. But since I didn't join him, later on I moved to NCL, and it's a very good point that he also moved to NCL. So again, we actually became colleagues. He was heading the polymer division, and I was heading the organic chemistry division. Later on, he became director, and I learned so many things from Dr. Shivaram. And we will take one full seminar to tell what all I learned from him professionally. I have observed him so closely, his managerial skills, balancing various things. And particularly, I think, important thing was when he established his polymer laboratories in NCL, he built new laboratories, the kind of laboratory planning, what is important. Coming from an industrial setup, I learned quite a lot about laboratory planning. And when he became director of NCL, at that time we didn't have any coursework for PhD students. He came up with the idea that we must have coursework, and then he asked me to lead the team. And we didn't have many good teachers at NCL, so we initiated a coursework, got into the teaching, attitude, and that helped me a lot, coming to IISER. But I was thanking him for one thing, all through my life, because when the IISER concept came, he was quite involved at the national level in various policy-making bodies regarding IISERs. Mr. Shivram and also Mr. Balram, they made the white paper on what should be the structure of IISERs, etc. And when IISERs, and also it was key, we played a key role along with Dr. Mashelkar in getting Pune, the first sign of the IISER to Pune. And if not for their efforts, probably Pune would not have got the IISER. And that was a fantastic move, because Pune is strategically an important place, particularly around NCL. There are about 10 to 15 institutions, where IISER can really be nurtured in a fantastic way. And after that, he actually asked me, in fact, he gave me a chance to conceive, create the team for the establishment, because we had to start in 2006, and he gave a lot of support and guidance, and he gave me a lot of freedom in establishing the IISER Pune initially, the planning. He gave me all the colleagues, his experience, and it was an amazing thing for me to learn how to nurture and mentor a new institute, because when you want to start an institute, you don't know where you start. So he laid out a very detailed plan, the administrative support, the infrastructure support, the scientific support, and also how we get it from NCL Pune, and identify very good colleagues. And I think if Pune has reached whatever the status today, there were 23 in the national ranking for this year, IISER Pune. So I think much of the credit has to go back to the initial stages, the kind of support what we received from Dr. Shivram, to establish the IISER. And he was on our board of governors, and he also mentored quite a lot. I think I cannot say anything. I think of the first person whom I run into is Shivram to ask for his advice. So I have a very close personal, contact, and I have gained quite a lot in my personal development, professional development, Shivram. So he has been associated in that way with IISER, right from the day one. So I think we can't have a better person than Shivram giving us this foundation day, and he is going to talk about what is chemistry, reflections from his own personal experience. Dr. Shivram.
Am I audible? Okay. Very good morning. Not loud enough. Thank you, Ganesh, for this very generous introduction. I guess all of us do what we need to do, and there was nothing more than that. But it's always good to be remembered for whatever little influence one has had on people. Because ultimately, I think all we leave behind in this world is not our academic credentials or awards and rewards. All that we leave behind are good friends who remember us. And I'm very fortunate in having large number of good friends in this country, whom we value together. And I think professionally that's been the most satisfying experience of having worked in this country for so long in science and technology. I'm delighted to be here this morning. I can see that you have made very impressive progress, and of course I'm not surprised at all, because with somebody like Ganesh at the helm, there's nothing else you can do, so I can expect. Okay, I think you made some fantastic progress in less than 4 years. To assemble a team, to assemble the academic program, to build new campuses, it's not a trivial task. And I think it requires some amount of not only abilities, but also abilities to energize people, to accomplish this task. And I think it's an amazing transformation that I've seen. I'm sure in the next few years, IISER Tirupati will grow to great heights of excellence. And I'm sure when you celebrate the 10th year of your foundation, I guess you will be right up at the top of the institutions, right up at the top of the institutions of India as one amongst the most premier ones. I don't know how many of you can see these. Some of these I have written as far as that behind. I see some people. Okay, I'll try to be simple and quick. When I was asked to give this talk, it came at a more opportune time because for the last 1 year or maybe less than a year, I've been wondering for some reason. It's it's a kind of an introspection of myself, and that was because there was a kind of a, just like we celebrate event every year, we celebrate a Foundation Day. We also look back at our life and see where we were and where we are. And it so happened that the first year that I spent full time in research was 50 years ago. Okay, so that was the first year. As a young man of 21, I spent my first full year in research. Okay, although I had 1 year earlier, but that was all spent in a classroom. And the first 1 year that I was put in the lab and asked to do research was exactly 50 years ago. And then I asked myself, okay, I've been around for 50 years. What has happened to chemistry in this last 50 years? Could we start thinking back of what chemistry was 50 years ago and what chemistry is now? And would that give us any kind of wisdom to see what chemistry will be in the next 50 years? Okay. For those of you who are trying to begin your early days of research, especially if you are a PhD student entering the lab for the first time, assuming that you are standing like this in a particular place 50 years from today, all right, what will it be chemistry like at that time? Okay, and are you preparing yourself today to face that future? That's a question I think many of us may want to ask, and therefore I said let me begin with a very deep introspective perspective. This is not a kind of a statement saying chemistry was this and chemistry will be this. I don't have the wisdom to tell you that, but it is a kind of an introspective analysis of what I have understood, of what chemistry was, has been. I will never say what it will be, because I can never say that, but all I will try to say at the end of the lecture is, what is it that we should prepare ourselves to face this future, and that's very important. Okay, I start with something which I even forgotten, okay? I don't even remember this. If you ask me what I wrote, I don't even know. But that's what I wrote in the first paper I published. And that happened to be the work I did in 1968-69. Okay? If you ask me what work I did, what did I publish at that time, I don't know. If you ask me what is written there, I would not be able to explain to you today. Okay? Maybe I've forgotten it. Okay? Did it make any difference to me? I will answer the question later, okay? Because when you publish your first paper, it's the most important point in your life, okay? Let me understand that. I mean, if you're students, when you publish your first paper, it's probably the crowning achievement of your life, okay? But then, 50 years later, it recedes into your background, okay? And that's very important to also understand. So what is most important when you're 21 is not necessarily very important when you're 71. Okay, this is the first paper I wrote. And this was, as I told you, published in 1972, but this work was done in 68, 69, roughly 50 years ago. What we were trying to do at that point of time, in fact, I went and read that paper again to write this summary. Okay, what we were trying to do at that time was trying to look at how carbocations, in those days we used to call it carbonium ions, it later on became carbocations, but in those days, in fact, this paper will all talk about carbonium ions, and how carbocation pairs in solution exist as either contact ion pairs or solvent separated ion pairs, and how does this structure of ion pair control the stereochemistry? Okay, especially when a carbocation dissociates and then to form back a carbon-carbon bond, we all know from a very fundamental physical organic chemistry that you have a racemization, because the carbocation is supposed to be symmetric, and therefore you should have a racemization. But very often you don't get racemization, you do get retentions. Okay, the question is what defines the stereochemistry of carbon-carbon bond formation when you generate a carbocation which is dissociated and then you go back to a tetrahedral carbon. Okay, so this was the question at the time. So we probed this chemistry. It was a very interesting chemistry to me at that point of time, because carbocations are not, we were taught that carbocations were symmetric and therefore racemization was expected, but then we found that in some cases you don't get racemization. What were the tools that we used for this at that time? A 600 megahertz NMR, 60 megahertz NMR, I'm sorry, a 60 megahertz NMR, a polarimeter, which is a very simple equipment. We used to just measure optical rotation in a polarimeter, and a few burettes and pipets to do kinetic measurements. And that's it. And using these three techniques is what this paper was published in Journal of American Chemical Society. Today you can't publish this paper if you do all these things. Okay? So that was 1969-70. Okay. Well, it so happened that just this week we have a paper published. Okay. All right. So in this paper, what are we trying to do? We are also examining ion pairs. Okay. It's very interesting. So I thought, what am I trying to do? In 1972, I was looking at ion pairs. In 1969, I was trying to look at ion pairs. In 2019, also I seem to be interested in looking at ion pairs. All right. What we are now doing, we are looking at ion pairing, but we're not looking at carbon ion pairing. We are looking at ion pairing of an electrolyte, of a lithium hexafluorophosphate in an organic solvent, which is an electrolyte solvent, and trying to figure out how does this ion pairing occurs. And what is the influence of this ion pairing on the conductivity of this material? As you know, this is the basic workhorse electrolyte in a lithium-ion battery. Okay, so in lithium-ion battery, you have a lithium hexafluorophosphate, which you are dissolving in an organic electrolyte, which is dimethyl carbonate and lithium carbonate. Obviously, there is an ionization, which is, of course, we all know well. But what happens? What is the role of these carbonate solvents? Okay. Why do we have to use these carbonate solvents? Why can't we use some other solvent? And what is it that defines the conductivity of lithium hexafluorophosphate under these conditions? So we are looking at whether they are contact ion pairs, they are solvent coordinated ion pairs, or solvent separated ion pairs. But then the tools that we are now using, you can see here is high resolution NMR. We are using ion diffusion rate measurements by NMR. We are actually literally being able to measure ion diffusion rate by NMR. We are actually doing electrochemical measurement to correlate the ion diffusion rates as measured by NMR with electrochemical performances. And this is important today because this leads us to an understanding of why batteries function the way they function. Okay. So what I'm trying to say is nothing has changed in 70 years. All right. I'm still interested in similar questions. Maybe the systems have changed, but nothing really has changed in terms of chemistry, okay? And that's the way I look at it. And the question is that really true? Well, there's another way I can look at change in chemistry. I think this is more understandable to many of you. And that is Nobel Prize in Chemistry, okay? So you look at Nobel Prize in Chemistry. When I was a student of chemistry, a young student learning the fine art of chemistry in the laboratory, who were the people who got the Nobel Prizes during that period? All right? Lars von Saget, the thermodynamics of irreversible processes, Derek Barton and Otto Hassel, conformation of molecules, Geoffrey Wilkinson, synthesis of organometallic compounds, Paul Flory, physical chemistry of macromolecules. I don't put the year, but this is roughly the period where I was deeply involved in learning chemistry. These were the people who got the Nobel Prize. In fact, my own interest in macromolecules actually, was essentially because I liked the way Flory approached the understanding of large molecule, and in fact we started learning about fluorine's contribution to understanding the behavior of large molecules, and that actually led me to my subsequent interest in polymers, in macromolecules, synthetic polymers. Well, if you are a student today, and I like many of you, what are you seeing today? You are seeing today the Nobel Prizes. Of course, the last one, directed evolution of enzymes, phage display of peptides and antibodies, cryo-electron microscopy for the determination of structure of biomacromolecules, design of molecular motors, mechanism of DNA repair. The question is this chemistry? All right. I thought that was chemistry. Okay. I thought this is chemistry. All right. I don't know. Is this chemistry? But the Nobel Prize people, the people who decide the Nobel Prize, seem to think that this is chemistry. Right? The question is, how many of the students of chemistry today who are learning chemistry can appreciate the science behind some of these discoveries? Are we still teaching and learning chemistry to understand this kind of discoveries? Or are we also learning more? I mean, of course, you have to understand that type of discoveries, but we also are teaching our students of chemistry to understand these kinds of discoveries. That's a question also worth asking, because that's the change that has happened. So in earlier slide, I said there is no change between what I learned in 1972 and what I am probably doing in 2019. But when I look at this, I get a little doubt. Is the chemistry same? So my next few minutes of talking, will be to exemplify this a little bit quickly using some anecdotal information. I don't want to burden you with too many details. I just want to use some anecdotal information, including some history, because we must understand the history. If you don't understand the history, you don't understand what's happening today. So I'm going to do that, okay? So what I'm going to ask is the following questions. In fact, this is the question I asked. What does this tell us about how chemistry has changed? Okay? I mean, do we have an understanding of how chemistry has changed? Well, the question is, has chemistry really changed? I'll try and answer these questions by the time I come to the end of my talk. Have the tools to examine chemistry changed? I'm sure many of you can start answering these questions yourself. Have the manner of choosing the problem changed? Has the manner of seeking solutions to the problem changed? What is chemistry that we may teach? What you might want to learn today if you wish to be a successful practitioner of chemistry 30 to 50 years from today. Some of you are starting to learn chemistry today, will practice this chemistry for the next 30 to 50 years. So what is it that you want to learn today? And what forces will shape the future of chemistry? Now this is a very broad sweep range of questions. Don't expect me to answer all of them either. I don't have the answers to many of them, but I will try to provide you with some perspective that I have on this. Okay. Well, the answers must be subjective because this cannot have an objective answer. And I use this metaphor of an allegory, which says the blind men were asked to describe an elephant, right? So all the men were blind, and they were asked to describe what an elephant looks like. So everybody touched an elephant, and then they gave a description of the elephant. So it was converted into a very famous poem by John Sachs, written in 1872, which said that these men of Hindustan disputed loud and long, each in his own opinion, exceeding stiff and strong, which is what we all do. So each one was partly right, but all were in the wrong. Okay, so that's what chemistry is all about. Okay, all of us look at chemistry and say this is chemistry. I think each one of us is right, but all of us put together are all wrong. Okay, and that's what chemistry is all about today. All right. So why is this chemistry so difficult to describe and understand? Is because of the origins of chemistry. Okay, and the origins of chemistry actually dates back to the alchemists. Okay, chemistry was not discovered as a science. Chemistry was discovered as an art. Okay, chemistry never emerged as a science in the first place. It was discovered as an art, and an art that was kept secret. In never disclosed, because chemists felt that they had the power to create wealth. Okay, and if you have the power to create wealth, you don't share with your neighbor, right? All right, because you want to be rich, not your neighbor. So, well, that's what the chemists did, and the chemists were all alchemists. In fact, this is the first alchemist who discovered phosphorus. Is basically called the Helen Brand of Hamburg. In fact, much of these kinds of laboratories are actually part of art today. In fact, we don't know how their lab really look like, but there are artist creation. This is, Henning Brand showing, that white phosphorescence of phosphorus, and he observed it in a flask, and he thought that God has revealed himself to him. Okay, because you see that kind of light only when God reveals yourself to him. So he immediately kneeled and prayed, because he thought that God has revealed himself to him. In fact, he discovered the phosphorus. Incidentally, the method that he used to make red phosphorus, is the same method we use today to make red phosphorus, which is taking a phosphate from an earth mineral ore, reducing with carbon, and to make red phosphorus, white phosphorus. And therefore, the technology of manufacture of phosphorus, even today, with some refinement, the principles originated from Henning Brand. Okay, I mean, he showed us how to reduce phosphate with carbon to phosphorus. Okay, and carbon dioxide. All right. Now, the art essentially became an adjunct to medicine, because most of the early elements of chemistry were used as medicine. And therefore, the science of chemistry was never developed. It became an art, became an adjunct discipline to medicine. And that's how chemistry began. Okay? Chemistry did not have an identity in those days. All right. It was actually one man, and I think this man we must recognize, who really created the first identity for chemistry. And this is a man whom we call Lavoisier, which many of you are aware. In fact, he was the one who said, people said chemistry lacked a Newton or Copernicus. Who is equivalent to a Newton or Copernicus in chemistry? There was nobody. Okay, and somebody said we have to bring chemistry to a level of science. Lavoisier's exposition of oxidation, the role of oxygen in oxidation reaction, gave the first fundamental principle of chemistry, and therefore this is how the science of chemistry was born. And therefore, it was only after Lavoisier that chemistry was given an independent identity in the hierarchy of science. Before Lavoisier, chemistry was never. In fact, the first chair of chemistry was established in 1749. The first journal devoted to chemistry appeared in 1778. And of course, the first international conference on chemistry was organized in 1786. So this was the beginning, in opinion, of the science of chemistry. He also wrote the first book on chemistry, called the Elementary Treatise on Chemistry. Unfortunately, as many of you are aware of, this is, I don't know how many of you are aware of, at the French Revolution, he was guillotined. Lavoisier was put on the guillotine and killed, and he was, because he represented what is called aristocracy, and they didn't like any of the aristocrats. And of course, Joseph Lagrange, a very well-known mathematician of the time, said it took them only an instant to cut off his head. But 100 years later, it sufficed to produce one head like him. And that was the contribution of Lavoisier. So we consider Lavoisier as the man who created chemistry for us. Well, chemistry still was not accepted, in many forums as a science, and because everybody said this is alchemical, this is some kind of a magic these people do. There is no science here. And in fact, it was actually the fact that chemistry was done in a laboratory. Mathematics was not done in a laboratory. Okay, physics was not done in a laboratory in those days. Only chemistry people used to work with chemicals and fumes and heating and cooling and things like that. So they said this seems like a craft. Okay, where is science here? It seems some kind of a craft. And chemistry was believed to depend upon empirical acquisition of knowledge. Okay, and practical laboratory work stigmatized the discipline. In fact, Immanuel Kant, which I'm sure many of you must have heard of, in 1786, he refused to believe that chemistry is a science. Okay, in fact, he said that chemistry is nothing more than a systematic art or an experimental doctrine, but never become a true science, because the principles thereof are purely empirical. And that was the belief at that point of time. We're talking about 1786. And therefore, chemists had to come up with what I call a justification to make their discipline as a science. Okay? They had no basis to think of chemistry as a science. Everybody was saying chemistry is not a science. The question is, how do you create a science out of something which people are saying is not a science? So there was this clever jargon that was created. Somebody said chemistry must be classified into two types, pure and applied. Okay? And applied chemistry is what is the one that is done, which people said is a craft, but pure chemistry could be very scientific. Okay? And therefore, this division of pure and applied was created at that point of time. In fact, it later was brought into physics, pure and applied physics. It was much later it was brought into mathematics, pure and applied mathematics. Okay? It was a chemist who thought about this enormously, what I call clever definition of chemistry as pure and applied chemistry. In fact, IUPAC, the International Union of Pure and Applied Chemistry, is still there, the name, okay? Although people don't know what is pure and what is applied today, but that's the way it is. And that was created, the term pure chemistry emerged to elevate the prestige of chemistry to the status enjoyed by mathematics and physics, okay? Because we have to become like mathematicians and physicists, okay? All right. Now, in spite of this Herculean effort, people didn't, there was no great credibility for chemistry until about the 18th century. In fact, chemistry was always thought about as chemistry's purpose is to make the gifts of nature easier to choose for human benefit. Johann Mann was the first professor of chemistry at the University of Cologne in Germany, and he said this. So chemistry was always driven by what is called, and I will come to you later, utilitarian ends. Chemistry had to deliver something to the people, and that was the way chemistry was conceived and executed for more than 200 years. There's a recent book, if those of you are interested to read this, it's a beautiful book. It's a 2012, not very recent. And in fact, there have been a couple of articles in the literature too, and they call it the chemistry is an impure science. Okay, the reason is, this pure and applied chemistry has been a battle. Later on, it became industry did applied chemistry, academia did pure chemistry. So academia is therefore higher than industry. Okay, this kind of structural hierarchy started building in chemistry. Okay, so people in academic laboratories said, "Oh, we are fundamental, we are pure chemists." Okay, as if there is another chemistry which is impure chemistry. Okay, all right. Now, so that's the title of this book. And it says, but perhaps chemistry is not as impure as its reputation. Okay, so that's the judgment that the author makes. I think chemistry is unique in its practice. It's also unique in its philosophical foundation, and that's why this conflict of chemistry from pure and applied, pure and impure, basic and not so basic. All these things come because people are trying to justify chemistry as a science, even today. Okay, to some extent, and this is a hangover of our past. Okay, of our 200 years legacy, we are still trying to justify today. Okay, and that's the reality. Okay, we have to get out of this mindset, but then it's not easy to get rid of the baggages of your history very easily. Okay, well, then what happens is suddenly in the early part of 1900 there was a revolution, and once again chemistry lost its race. Okay. Here what happened was, essentially the atomic theory came up, and everybody said chemistry is nothing but electron, neutrons, and protons. Okay, what else is there in chemistry? Everything is electron, protons, and neutrons, and we understand electrons, neutrons, and protons by the early part of the 20th century. Once we started understanding quantum mechanics and the structure of the atom, they said, what is there more in chemistry? They have understood all chemistry, right? Everything is electrons, protons, and neutrons. And therefore, Paul Dirac made this beautiful statement, as you know, that all problems in chemistry are problems in applied mathematics. So he said chemistry again does not exist. Okay? So after so much struggle of trying to establish an identity for chemistry, once again chemistry lost the race. Because everybody said now, he said everything can be reduced to an atom, and once it's reduced to an atom, we all understand that, right? So it doesn't make a difference what is chemistry. Everything is reduced to an atom, okay? And once you reduce to an atom,
the molecules to an atom, atom to the electronic structure. And therefore, if you know the electronic structure, you have understood all chemistry. Well, that was the basis. And this was how, they said that all complex systems can be understood as the sum of its parts. And this was the beginning of what is called the reductionist philosophy in science, which is a separate topic of discussion if somebody is interested. But that's a very damaging philosophy in science that came to haunt scientists for over 100 years. And that reductionist philosophy is even again, just like I talked about how we are trying to get over the baggages of the origins of chemistry today, we are still trying to get rid of this reductionist mentality in order to solve complex problems that we face today. Because many of the complex problems that we face today cannot be solved using a reductionist philosophy. Okay, and that's the point which I will probably make in the end of my talk. Well, what is chemistry? Therefore, chemistry defines itself post-quantum theory as the science of atoms, molecules, and matter. It tends to focus on molecules. Okay, all right. Chemists can make or obtain from nature an enormous range of molecules today to determine the structure, even at extraordinary levels of complexity. Chemistry is, and I hold this true even today, irrespective of what my theoretical chemists are the people who do theory in chemistry tell me, that chemistry is primarily a qualitative intuitive science. It was a qualitative intuitive science at the time of the alchemists. It is still today. If you ask an average chemist, when he thinks about chemistry, does he think about Schrodinger equation? Or does he think about something else? Okay? Now you must ask him, when he wants to plan a chemical reaction in the laboratory, does he invoke a Schrodinger equation? Okay? Or he thinks about it in a different way. And that's the difference. To me, chemistry continues to be a qualitative and intuitive science. And I think the greatest benefit to chemistry has been because it has been a qualitative intuitive science. Theory, of course, has enormously helped our appreciation of chemistry, but you cannot forget the fact that chemists, by training, are intuitive and they think in physicals, in terms of some physical principles, which may or may not have any theoretical underpinnings. Okay, but it helps them to navigate the chemistry. Chemistry is, of course, uniquely utilitarian, and I think this we cannot forget about it because chemistry has been used by mankind. Okay, this is again unique, in my opinion. And chemistry, one of the reasons why chemistry is blamed today is because of all the benefit it has brought to the mankind. And therefore today we are blaming chemistry for some of the, side effects of these benefits. Well, as I said, disruptive revolutions in chemistry come periodically. I think one happened when there was this quantum chemistry that emerged that gave us a new understanding of what chemistry was post 1900 and 1910. And of course, another thing that has substantially changed chemistry is the availability or the emergence of tools to examine chemistry. I won't have time to talk about that today. Well, this is what I said. This is true to me. You can decide how much of it is true to any one of you. Even today, when I look at chemistry, I want to do something in the lab, I only think in terms of very qualitative terms in order to plan my experiments, in order to design what I want to do. Okay? I don't do a theoretical calculation. Okay? I may do a theoretical calculation or ask my friends to help me to do some kind of a simulation, but that is only to validate my qualitative thinking. Okay, that I'm not totally wrong. Okay, but what is it that look at all these terms that all of you use every day. Much of it we only look at it in a very qualitative manner. Okay, but it helps us, in our daily work. I just list them here. I think I don't want to go through them. But many of them have theoretical underpinnings. I'm not denying that. But when a chemist thinks of it, he looks at it in a very intuitive and a qualitative way. Some of them have no theoretical underpinnings, by the way. For example, steric effects. There is no theoretical underpinnings for steric effects. Although chemists use steric effects routinely to understand why certain chemical reactions proceed and why certain chemical reactions do not proceed. But there is no theoretical underpinning for a steric effect in a true sense of the term. Okay, there is no theory to the best of our knowledge today. You can talk about crowding, but there is no theory that predicts steric effects by an equation. Okay, now there are many more. I think some of the best chemists of the world have helped us to create this nomenclature. People like G.N. Lewis, Linus Pauling. They were basically people who only looked at chemistry in a holistic way and tried to appreciate what is happening, at a molecular level. And all of them are, to me, very, 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 very vague concepts that we use in chemistry. In fact, I just gave you an example. We talked about the International Year of the Periodic Table this year, okay? And there's an article which is worth reading by Philip Paul, in January 2019. We use the word element, okay? We still do not know what an element is, okay? All right? If I ask 10 people what is an element, I'll get 10 different answers, okay? That's why I said it is like the blind men of Hindustan, okay? All of them are right, but together then, there is something still incomplete, and that's what I talked about. So element is, we don't know still what is an element, but we use this word, in every conversation in chemistry, element. But what is an element? For example, I asked this question, what do we mean by carbon? Is it a diamond is a carbon? An atom with atomic number 6 is carbon? A C60 is carbon? A graphene is carbon? What is an element here? I don't know, okay? But we are very comfortable using this word elements, There are many other ways we can look at it. If elements are defined by chemical properties, can we include heavy man-made elements which exist only at a few atoms and for less than a few seconds? Is nucleus an element? Radiochemists think the nucleus is an element, but chemists may have difficulty in accepting that definition of element. What is more important? Number of protons or the number of electrons and the configuration energy levels, which is more important, okay, in element? Well, answer is still up in the wind. If conservation of mass is integral to our understanding of chemistry, is radiochemistry true chemistry? In radiochemistry, there is no conservation of mass, okay, in the true sense of the term. The question basically, is it true chemistry? Well, these are questions that we can keep asking. My feeling is that we have no answers to many of these questions too, even today. And therefore, I only illustrate this by saying that an age-old terminology like element is still not very clear in our mind, but it has not, in my opinion, hampered the progress of chemistry. Because the beauty of chemistry is that we are perfectly comfortable using concepts that are no unique or precise definition. Okay? This is not true of physics and mathematics. Okay? And chemists, can use very vague terminologies and move ahead with the progress of science, as I said, without diminishing the value of the field. And that is the way chemistry is structured today. In fact, G.N. Lewis himself said this at some point of time, that chemistry, or the chemist does not seek the ultimate, but the proximate. He does not speak of the last analysis, but rather of the next approximation. It's beautiful, And this is G.N. Lewis, okay? The man who has probably the most outstanding contribution to chemistry in the last 200 years, okay? And he also said exactly what I said about the 7 blind men of Hindustan. He said that for while chemistry will never be wholly right, it certainly is never wholly wrong. Okay? I think it tells you something about what chemistry is all about. Okay? And that's what I have appreciated in the last 50 years, that this is what keeps chemists going to a large extent, in the laboratories, trying to figure out things to do, how to do, without having that deep underpinning of what is called a classical science, behind it. Okay, and that's where I think chemistry has progressed. I think this is a tribute to G.N. Lewis. He wrote this in 1926, in a book called The Anatomy of Science, which is again a very beautiful book. If those of you want to read, it's free for download on the Gutenberg library. Okay. What do chemists do? Chemists make molecules, okay? They synthesize. So core of chemistry is synthesis. They all make molecules in some form or the other, okay? I think the highest form of creativity is the use of chemical reactions to generate a desirable product, structurally distinct from its precursors. I use the word desirable in inverted commas because sometimes we do make undesirable products, and that is what causes us problems. Okay, but our goal is to make desirable products, but we don't always succeed. That's the problem. And synthesis is therefore the defining character of chemistry that actually distinguishes it from other physical science. And in fact, this is what was said not by me, but this gentleman, whom I think is probably should be. In fact, he came a little later than Lavoisier, another brilliant French chemist called Marcel Berthollet. And what he said was chemistry creates its own objects. It is creative power similar to the art. So as you see, that chemistry is likened to an art. Okay? Distinguishes itself fundamentally from other natural and historical sciences. Okay? And of course, Richard Feynman, with all his wisdom, he said, what I cannot create, I cannot understand. Okay? So chemistry can create, and therefore they understand. Okay? Now you understand why it's so difficult to understand biology. Because we don't create in biology. Okay? The day you create life, you will say, I understand biology. Okay? Because you have not created life so far. Okay? So we are still struggling. Chemists feel we can create anything in the laboratory, right? You give them a set of atoms, they will make anything that you want. And therefore, the fact that they create, they understand everything. Okay? And that's why the difference, And therefore, you see here, this is what was created in 1828, right? A simple molecule called urea, right? And then what happened in 1972, this was time when I was doing my PhD, the hottest subject when I was doing my PhD, the most spectacular scientist whom we all run to hear was a man called Robert Burns Woodward, who in 1972 announced the synthesis of vitamin B12. Okay? And when Robert Burns Woodward used to give a talk, just like Ganesh was said, it would be like a political rally. Okay? There will be 500 people and 700 people in the lecture room. Okay? Because he was a star, because he was considered a wizard because he could make these molecules, okay? And this molecule is the one that he made. By the way, this molecule required the efforts of 91 PhDs and 29 postdocs, okay? All right, and it spanned the effort of 11 years, okay? Imagine that kind of patience. Will you get a grant for this today? No, okay? Now, Woodward at Harvard, 91 PhDs, 29 postdocs together over a period of 12 years. They started this synthesis of vitamin B12 in 1960, he announced it in 1973. Okay. 13 years, okay, is what effort that went into this. Okay. Well, it didn't end there. In fact, I think this is considered to be the Mount Everest of synthesis in organic chemistry. It's a molecule pyridoxine. It is actually the most toxic non-protein molecule known. It's an amazing molecule. Look at this. It has got 64 chiral centers, 7 double bonds with isomerism. Okay, Z and E. Okay, and it's got an atomic weight of 2,675.8 million. Huge molecule. Okay, and he put together this molecule. Okay, so the question basically is that today chemists can put together any molecule. So what's new? Okay, you want to put another molecule together? Is there something new? In fact, today, honestly speaking, there is no great support for research when people say we want to make a complex molecule. Nowhere in the world. Okay, people are no longer funded for this research. In fact, there's a classic example of somebody who abandoned a big synthesis agenda because the grant funding agency in America said we don't want to fund it anymore. Okay, all right. It has actually evolved to a fine art today. Anything chemist wishes they can do. In fact, today there are robotic machines that can do chemical synthesis. Okay, in fact, that is the current generation of technology. There are Chematica, there are a couple of others. There is actually a thing called Atoms. There's a machine called Atoms and Eve, and they are able to. You can give the algorithms. You can make any molecule you want. In fact, there are 3 drug molecules that have been made by an algorithm. By these machines already. So maybe in the future, chemists will not be required to make complex molecules. Okay, so that's we must understand. Well, So what is the future of these molecules then? If you don't want to synthesize, what else can you do? Okay. The question is, we must understand the future of chemistry is not molecules anymore. It has to be systems. Okay. And the functions are becoming more important than their structure. And that's what it's no longer what is it, but what does it do becomes more important. So it's no longer saying, okay, I've got a compound, what is it? The question is now, what does it do has become more important. And I think that is the reason why today everybody is looking at how do you transition from molecules to a functional, whatever you want the function to deliver. Okay? And therefore, you have to go through molecules to functionality, through design, and eventually function and response. And I think that has become, the preoccupation of chemists worldwide today. I just want to only show you, in fact, I think that today, if you ask what chemists in some areas which I am familiar with, I'm not talking about areas where I'm not familiar with, there are also many things chemists can do. But in an area where I think is very important for the planet, I think chemists are mostly concerned with what is called energy conversions. And I think we have come back to that core definition of what is essentially energy and how do we interconvert these energies efficiently. And I think that has become, whether we're talking about any of these areas that we talk about, like Dr. Ganesh talked about energy, I think that is the thing. And I think Nicholas Tesla, in my opinion, the man who probably did the most to energy, that if you want to find out the secret of the universe, think in terms of energy, frequency, and vibration. And I think that's what the chemists are interested in today. Okay, so ultimately, you want to convert energy, and therefore you want to convert energy from light to electricity. You want to convert, into hydrogen to electricity. You want to convert, something that you have electricity, how to store and how to release this electricity. All kinds of conversion of charge that you want to store, you want to transform. This has become the endeavor of chemistry. Now, if this is all chemistry, then what is it this chemistry is all about? This chemistry is not about a single molecule, anymore. This chemistry is about a complex web of structures and molecules which all have to cooperatively function to deliver the end results. And that has become the complexity of the chemistry today. So you can look at this chemistry and say, is it organic chemistry? Is it inorganic chemistry? Is it physical chemistry? Is it polymer chemistry? I don't know. Okay? And therefore, the question is, if you want to characterize them, all this chemistry, especially when I talk about energy interconversions, is hierarchical materials, hybrid materials. They have microphases in morphology. They have interfaces and molecular junctions. They have multiple molecules cooperatively defining responses and functions. So that's the key. That's the key to understanding of these things. And therefore, the processes involved are very diverse. Electrochemistry, catalysis, polymers, ion diffusion and transport, nodal accept resistance, electron and proton transfer, oxygen reduction, porous material, conducting materials. So whole area is all chemistry today. Because ultimately the principles of chemistry work in all these areas. So the point I'm trying to say is the character of chemistry is changing substantively, although the basics of chemistry have not changed. Okay? The basics of chemistry is still the same, but the character has changed substantially. All right. In fact, that's where chemistry is believed to bridge physics and biology to some extent. And people said that chemistry and biology are two distinctive cultures, and the drift between them is serious, generally unappreciated and counterproductive. And this was, of course, said in another mind of the convert. Okay, and I think we are still in the same place today, more or less. Although substantial improvements have been made since 1987, and we are still in the same place today. All right. In fact, the language of chemistry is what connects the physical world to the biological world. Okay, and we believe in the language of chemistry, but then I don't think the appreciation is still there at the early stages of education that this is indeed the bridge that is connecting the physical to the biological world. Okay? And in fact, if you want to understand the humanity or the social structure of humanity as a whole, we need to understand the physical world, we need to understand the biological world, and of course, we need to understand the human world. You know, and between the three, there are bridges that we need to connect. And it's the bridges that is going to be very important. Otherwise, you will never be able to understand the relationship between the physical world to the biological world to the human world. And I think that is very important in opinion as we look at chemistry. Well, what is happening therefore is chemistry is becoming complex. So that's why I said the reductionist approach that was originally came as a result of the quantum mechanics in the early part of 1900s gave a reductionist approach to chemist thinking, okay, saying that everything should be understood in terms of electronic structure. And today, that same reductionist thinking, which is kind of, embedded into generations of chemists trained, are actually becoming limiting for them to look at what is called complex systems. Because in complex system, you don't need, you cannot use reductionist approach. And therefore, the beginning of the concept of emergent properties, when whole becomes larger than the sum of the parts, and therefore biology is characterized by emergent properties. And that is one of the reasons why chemists find it very difficult, to migrate into what is called modern biology. Because there is a kind of a mindset which is completely different in our thinking process. Okay? And the thinking process, because we are trained as reductionists in terms of our philosophy of thinking, whereas we don't understand, this what is called the whole approach to a science, or to a phenomenon. And therefore, a lot of things is happening today in trying to break this philosophical underpinning between chemistry and biology. Most people believe the reductionist approach limits our ability to understand emergent properties. By the way, this is not only true in biology. I told you about some of the multifunctional materials, multi-hierarchical materials. Once again, they are all emergent properties. Okay, not one of those individually create those final properties that you want in these materials. And therefore, is there a new stream of thoughts to connect the simple molecular understanding of matter provided by chemistry with the complex emergent behavior of biological system or even, let's say, non-biological systems. And therefore, life is not mere chemistry. Okay? Because many people argue, oh, chemistry is all about life. Okay? But no, it's not true. Okay? Chemistry is important in life, but it's not necessary and sufficient condition. Life is not mere chemistry. Life is something more than just chemistry. And what is that more is what we do not know at this point of time. Well, therefore, one of the ways to relate physical and biological world was actually the discovery in 1987, the Nobel Prize, which I think is a watershed moment in the history of chemistry, which kind of said that you can relate physical world to the biological world through these principles of chemistry that we talk about here. And that led to a resurgence of chemistry. In fact, you can see here that today, people are looking at whether chemistry should be looked in terms of non-covalent synthetic chemistry. Okay, we have been focused too much on covalent synthetic chemistry. Is there a role to look at for non-covalent synthetic chemistry? And in fact, the area of non-covalent synthetic chemistry is still very nascent. We cannot put together complex molecules, by non-covalent synthesis. It's a very early stage. If those who are interested in reading a nice perspective, just appeared in 2019 Science. Please read it. It's a beautiful perspective to understand what the challenges here are. Well, there are lots of chemistry that is inspired by biology. And I think we are all aware of this, and this is very important. And I think this is an area which is of great importance. He talks about bioacoustics. I think it's a very important area to understand how nature produces complex phenomena, that we cannot even think of producing in a laboratory. I don't want to discuss this. You all know this. There are all kinds of things that nature produces. We don't know how to produce them. Okay? We don't even know how nature does this. Okay? And therefore, there's a whole lot of things that we need to understand. We say nature's materials are the most advanced on this planet. Okay? How does a leaf, create energy? Okay, which is so ubiquitous around us. All kinds of leaves are transforming energy. Okay, we can't seem to do this in the laboratory with similar efficiencies or similar conditions. How do animals, create fantastic adhesives? In fact, this particular thing has been studied so much in detail today. In terms of how do these things function, because they are able to stick to wet surfaces. There is no synthetic adhesive today that we know in man, which I can use it for wet surfaces. We don't know how to do it. We can do for dry surfaces. We don't know how to do it for wet surfaces. How does this do for wet surfaces? And lastly, of course, architecture and nanoscale, the colors of nature. How does nature produce these brilliant colors? They don't use a paint. How does it produce these brilliant colors? There's a beautiful book, those of you who want to read, called Structural Colors in the Realm of Nature. Beautiful book by a Japanese author, which tries to understand these scientific phenomena. I think it could be a forerunner for somebody to start thinking, how to reproduce these kinds of colors in man-made systems. It's an amazing book that some of you might wish to read. Well, I always say this, a lowly mosquito, okay, look at this, can differentiate an O-type blood with an A-type with 66% accuracy, okay? Can you believe this? How do they do it? Can detect carbon dioxide in air from 165 feet away, okay? Can detect trace quantities of lactic acid, uric acid, and ammonia in sweat. Can detect a temperature difference of 1.3 degrees, 1.3 Fahrenheit. Has a night vision for black, dark blue, and red colors. Now if you are going to be safe from mosquitoes, you see that it has a dark vision, okay, for black, dark blue, and red colors. Okay? How do they do it? Okay. In fact, all these are enormous, benefits to mankind. And a lowly mosquito has the power to do this. Man cannot do any one of this. Okay. We cannot do this. And I find this amazing, the one mosquito, what power it has. Well, the last point I want to make before I close is that chemistry, of course, is very key to sustainability. I do not want to discuss too much about sustainability. In fact, in IISER Pune, we are trying to put together a sustainability curriculum, okay, for students, In IISER Calcutta and Pune, we are trying to put, maybe I should talk to you also on that. We are trying to do it on the network. And I think it's amazing because if you are going to be trained as chemists in the future, I think you must understand the principles of sustainability. Beyond the jargon, you must understand the scientific principles of sustainability. And I think it's very important because chemistry has a very important role to play in achieving sustainable civilization on Earth. And I think it gives us new meaning for us to pursue chemistry as a science. And I just show this one thing, the way we are currently extracting resources from this planet Earth today, this is non-metallic minerals, biomass, fossil energy carriers, metal ores. Look at that, This percent change in the last 40 years. We are extracting resources from this planet Earth at an unsustainable rate. Okay? If we continue to do this, we will need actually the equivalent of more than 2 planets to sustain us by 2100. We don't have those 2 planets. Okay? Where are we going to get our elements from? We are all getting all our basic building blocks from this planet Earth. And I think, therefore, chemists' appreciation of sustainability is an important thing. I delivered a series of 6 lectures. Ganesh, I delivered a series of 6 lectures on sustainability in IISER Calcutta last year. Okay? And it's very important for people to understand what sustainability is, why are we so concerned about it today. All right? And therefore, there is a whole lot of new terminology that is coming called dematerialization. How do we dematerialize our existence in this world? Okay? How do we create what is called a circular economy? Okay, and what role chemists will play in design of materials for these kinds of issues. And lastly, look at this periodic table. I think this you must have seen the year of the periodic table plenty of times. Your mobile phone, which all of you uses, you are using close to 30 elements in the periodic table in every one of your mobile phones. And that what I show here, you can see that limited availability, future risk to supply, rising threat from increased use, serious threat in the next 100 years. As we speak, gallium, by the way, gallium was one of the first elements predicted by Mendeleev, as to be existed. Gallium, as we speak today, has disappeared from the earth. There is no more gallium left on this earth. Okay, if you want to look at gallium, you may have to go to a museum. Okay. Why is it so? The reason is, after all, elements are indestructible, right? That's what somebody taught us long years ago. That all elements are indestructible. Nothing happens to an element. But what happens in reality is, except uranium and helium, as you know, helium is lighter than air, it escapes out, and uranium, of course, undergoes fission. But otherwise, all elements are indestructible, according to what we have been taught in chemistry. Is it true? Yes, scientifically it is true, but in practice it's not true, because human activity is taking elements from relatively concentrated ore deposits on this earth and distributing them so thinly across devices and gadgets that they are no longer easily recoverable. Can you imagine how much gadolinium can you recover from all your cell phones? It's very important. When your phone vibrates, it's a gadolinium magnet. Okay? When you put it on a vibration mode, every phone of yours has got a gadolinium. The question is, if we keep on using this material, how are we returning it back to the earth? Is a question that we have to ask. And therefore, is it sustainable to use these materials at all in the long term is an issue that I think chemists must worry about. And this is attracting a lot of attention. In fact, there's a paper that those of you want to read. It's again in Nature Chemistry in 2019. It is coming up in all these journals that you thought never worried about these mundane things, but Nature Chemistry also worries about this. And now you are talking about things called circular chemistry. Okay, how do I make chemistry circular? Okay, just green is not enough. Okay, there was a concept of green chemistry. Green chemistry is important, but you need to talk in terms of circular chemistry. There are issues that we must understand in applying the principles of circular chemistry in material design. And that is going to be very important for future chemists to think about. In my opinion, we have to close all the cycles. That's what it matters eventually. Okay? Nature revolves around certain key cycles. The carbon dioxide cycle, the hydrogen cycle, the carbon cycle, the nitrogen cycle. I call it the element cycle and the fuel cycles. How do I close all these cycles in a manner that I don't deplete the resources of this planet Earth? These are key questions that I think chemists of the future must ask, must understand. And I think, I don't want to get into this, this is a typical hydrogen cycle. One can talk in terms of what happens to hydrogen, one can talk in terms of what happens to fuel. I don't want to talk about this, we can discuss in detail. But I think these cycles will be understood in the concept and principles of chemistry. And I think it's very important for us to appreciate that these cycles are going to determine the future of this planet. And how chemists understand, manipulate, transform materials with an understanding of such cycles is going to be very important. Well, have we solved chemistry? The question was asked. In fact, there's a book which you want to read, 2019, which says Solving Chemistry. Are there any big discoveries to be made? Are there any major problems of structure and reactivity that we do not understand? In fact, such questions are not asked in physics or mathematics. Only in chemistry, people ask these questions. Okay? In physics and mathematics, nobody asks, have we reached the end of physics? Okay? In mathematics, nobody asks, have we reached the end of mathematics? But in chemistry, people ask, have we reached the end of chemistry? Okay? And there is a question that you can seek to find answers. In fact, I always say predictions are always precarious. In 1874, the thesis advisor of young Max Planck, he said, avoid theoretical physics because there is not much left to do. Okay? And so don't never believe your advisor. Okay? And Niels Bohr in 1915 said chemistry is solved. Okay? Because I understand electrons, protons, and neutrons, chemistry is solved. Nothing more to do in chemistry. In 1915, well, there are new challenges in chemistry which is coming. I'm very happy to see this science and engineering bridges that you are building. It's very important to do that. I think we need fresh thinking in these areas, you know. And I always said, and I have felt that disciplines are human constructions, a conservative, compartmentalizing affliction of a daily. And this was nothing but all. Okay? And I think disciplines were not invented. Disciplines were invented by people in the daily to satisfy the self-interest. Okay? It was not the intent of science to create disciplines. Challenge the teaching is always how to convey the flavor of these sciences, how to erase the boundaries between engineering and science, and of course, exemplify the so-called molecules to devices journey. I think that's going to be very important. Just don't teach them about molecules, but tell them how molecules get converted into certain objects that serve a function and how they serve a function. And I think that's what's going to be very important, in my opinion. So many things I think will change the future of chemistry. Tools and techniques, computational power, internet and IoT, digital technologies, automation and robotics, AI and big analytics. I don't know how much the chemistry curriculum must give a flavor of some of these to chemistry students. I feel it should be. Okay. I mean, chemistry students must get a flavor of these tools that will emerge. They will pick it up later, but I think they should not be scared of it in the early years of their life. Okay? And lastly, my answer to the question, has chemistry changed? Not really. That's my conclusion, you may disagree. Have the tools to examine chemistry changed? Yes, profoundly. Have the manner of choosing the problem changed? Yes, definitely. Have the manner of seeking solutions to the problem changed? Yes, absolutely. Problems that have greater relevance to the needs of humanity and our planet. That's the focus of chemistry today. What is chemistry that we may teach? I always have held this structure, dynamics, property, function, relationship with all molecules, mainly in small, large, living, or non-living. And I think that's very important. And lastly, what we may wish to learn beyond chemistry, because chemistry alone is not enough to survive in life. If you're a student, you must learn a few things beyond chemistry. Chemistry of the future I cannot predict, but this I can prepare myself. One is the spirit of collaboration, which is becoming increasingly called shared science. Okay, how do I share science? Today, as you know, all the world economy is moving to what's called shared economy. I hope you understand that. Okay, everything is shared economy, and therefore there's a principle of shared science that we must understand. Gain knowledge, of course, involves breadth and depth. Learn to appreciate the history, sociology, and philosophy of chemistry. I hope that this is something that students learn. It's very important, to understand this. The ability to learn, unlearn, and relearn. And lastly, courage to jump into uncharted waters, even at the risk of drowning. It's very important. Okay? Playing safe is no solution. And lastly, I think a statement from George Whiteside, which I think I like it. Chemistry, by its very culture, has been blindly reductionist, and that's the problem today. Okay? I'm often reminded that chemists work on molecules, but they must also work on problems that molecules may be only part of the solution. And I think that's very important to understand. We think of ourselves as experts in quarrying blocks from, but they are like rock cutters. They take a big granite and they cut them into pieces. They are not taught in our job to build cathedrals. I think ultimately chemists should not only quarry the rocks, must learn to build cathedrals that can be studied. So that's my talk today. I'm sorry if I
A change in perspective is worth 80 IQ points. And looking at chemistry, it feels like it is some 1000 ahead of us. So I like to say that this thing, If there was a kid sitting there among the audience, even he would understand what was being said here. Ultimately, that should be the goal of science. And sir started from basic, like what was the history from alchemy to coming to the cycles, that something that we all didn't know about, and that is really interesting. I'd like to thank sir that you changed our perspective today.
Thank you, sir. So this is the all institute. I'd like to request Professor Ganesh to present you a memento on the institute's behalf.
Swami.
So now we come to the much awaited event, the release of the 4th edition of the student magazine of IISER Tirupati, Dhwani. Dhwani is the brainchild of the creative minds at the institute and presents to you all the events on campus as perceived by the students here. We now invite Professor Shivaram to honor this release. We also request Professor Ganesh and the editorial team of Dhwani to be present on the stage to the stage.
Editorial team here or no? Come on. Money editorial team. All of you come. Oh, yeah. One more.
So the e-copies will be circulated shortly, and if you favor just flipping through the pages, then you should go to the library to do
Only
this.
e-copies, sustainability. Not printed.
Dhanyavadam. Thank you for the Dhwani release. Today is also the occasion to recognize the outstanding performance of the students, faculty, and staff members of the institute. Let us start with the award for students.
So we have our Dean Academics, Professor Ambika, to present the recipients of this year's academic awards. We request Professor Shivaram to hand over these awards.
Very good afternoon to all of you. It's my pleasure today to present before you the students who are going to receive the academic awards of this present year for their excellent performance in academics. I start by the endowment awards. We have one endowment award that is instituted by the C.N.R. Rao Education Foundation. This award goes to the best performer in the first semester and second semester of the BSMS program. So in the spring 2018, we have today, I would like to present Deepita Balasubramanian for her performance in The award comes with a certificate and a prize money. For best academic performance in semester 1 in Monsoon 2018, the award goes to Prarthana Agarwal. The institute would like to appreciate the academic performance in all other semesters of the BSMS program. So in spring 2018, I would like to present the best performing students of semester 4 and semester 6. In semester 4, the award goes to BC Pamaraivalli. The best academic performance in semester 6 of spring 2018 is shared by two students, Ranadeep Roy and Aditya Kulkarni. Both of them come with a perfect GPA of 10. Coming to Monsoon 2018, we present awards for performance in semester 3, 5 and 7. Semester 3 is shared by three students, Geetanjali TV, Abhinava Majinda, and Ishita Ghosh. Geetanjali TV, Abhinava Majumdar, and Ishika Ghosh. For best academic performance in semester 5 of Monsoon 2018, we present Renjita R. Again, perfect GPA of 10. For best performance in semester 7 of Monsoon 2018, again Aditya Kulkarni. Congratulations to all award winners.
joining us, and best wishes to all of them. Thank you.
Thank you, ma'am. Now we'd like to request Dr. Vasudharani Devanathan to present the awards for all the extracurricular activities that have been going on and all the other events.
Good morning, everyone. So, students who excel in academia and also show outstanding talent in overall institutional activities are recognized in the extracurricular award category. For the sports category, we would like to call up on stage Tamarai Valli. You can see her at 6:30 in the ground every day. Participates in math club, actively takes care of quiz club and science day activities. For the cultural category, we would like to call on stage Aditya S. from BSM Institute of IISER, winning the IICM Dwaita category, Speak McKay organization, Arts Club participation, and several other musical events that most of us have witnessed in the campus. For the cultural category, we would like to call on stage Uttara Khatri, BSMS 2016, for her contributions to consistently taking care of the quiz club. She also is a participant of IGEM. She also plays basketball, so hence participating in the IISM, and she was leading the team of finance in Vivante. We also would like to recognize two teams that work consistently throughout the year. So we would like to call on stage the Unnati team, the outreach wing of IISER Tirupati. We are showing that taking care of a lot of different schools in and around IISER Tirupati campus, and also conducting science quizzes and science day activities with different schools inside Tirupati. So one other team that one other team that worked throughout the year and put this techno-cultural fest in place was the Vivante team. So we would like to call them also on stage. Quickly, few of you come or take the certificates from the So we congratulate all the students for the hard work and for the awards that they have won. Keep continuing your extra activities as well. Thank you.
Thank you, ma'am. We now request Professor Ganesh to announce the awards for faculty and staff members.
Great pleasure in recognizing our staff for doing service to the institute beyond what is required to be done. So there is nothing like a quota system. We just recognize people based on the opinion of colleagues, and so these are the people who have done really outstanding or excellent work, what is called beyond the call of their duty. So I'll now call upon the names. So please do come over to the stage and receive the award. To start with, our engineer Shivakumar. And he's the only engineer who looked after the complete engineering works at IISER Tirupati. Electrical and everything. Now he's busy with the campus. Very sincere and very committed. Next is our engineer Anthony. He started in 2017 and he has taken up the various civil works in the transit campus, joining creation of several instrumental rooms, execution of hostel building in the transit campus for the faculty officers. Health is an important thing. So we have Mrs. Nimi Prasad. And she takes care of all the health issues. She makes sure that my BP is in the normal. She joined in 2016, and she's taking care of all the staff facilities and procurement of staff, related students, interaction with local hospitals, and immediate response to all medical emergencies, etc. I don't think this will come as a surprise. Next person is Datta Prasad. When you see food, you see Datta. Making sure that everybody else eats. He has overseen our dining and guest house related service, and also, he is also a public information officer for the RTI, which is very, very important. He's instrumental in setting up our guest house, inventory, dining services in the transit campus, very efficient in organizing and catering services to institute events and conferences. Because of him, wherever we go, we get Indian restaurants 10% discount. After you, Tara Chen, who is a teaching assistant in biology. His citation says that he handles sensitive and complex routine matters. Right from the initial days he's been doing it. He's a teaching assistant in biology. Next we have Mr. Kedarnath Meduri, who is an office assistant. And also, for quite some time, he worked in my office, rendered a fantastic service. Now he's taking care of academics, transport, related work, etc. Efficiently organizing all the BSMS admissions, sending information to JAC, etc. We next have Mr. M. Vamsidhar, who is an office assistant. He oversees all the office related work. Working efficiently in paying the bills. Mr. V. Tirupati, who is a lab technician. You have clearly said how popular he is. Assisting all the indent for consumables related research labs, maintaining records, actively participates in all running UG labs, follow-up of indents, etc. Mr. Muni Kumar, who is a housekeeping supervisor. Most of you may not have even seen him, I'm sure all of you will give a thunderous applause. Mr. Venugopal, head cook. Serves delicious South Indian food in the guest house. Very sincere. Mr. Balaji, driver. He is available almost round the clock, drives the ambulance during night emergency time. And also, he has been, very mighty. Mr. Vandi Rajesh Kumar, who is in academic section. He was doing it right from the beginning almost, and assisting the academic section in government attendance. So, doing the various fights, taking the visitors and guests to, and he's the one who helps us with a lot of arranging, tickets for our DTD that time. Mr. Durmasala Naidu, who is security, he joined in 2015. He only retired recently in February 2019. Srimati Yasoda, who is the security female guard. She also joined in 2015. In the first year, she also served as our assistant warden in the first 1 year for the girls' hospital. Very good. I'm sure in the executive you have not seen very many leaking taps or floods. That's because of Mr. Pawan Kumar, who is a plumber. In the institute, we do not have very many places where air conditioner is there, but it is not working. That's because of Mr. Rahmatullah. And finally, from this year onwards, we also recognize a faculty who has been doing things beyond what is required to be done. There is the teaching, research, but always caring for everybody on the campus. And when answered there, I'm sure, you will all build up an image of the faculty, what all this faculty has done. Very committed, always available, very calm, deals with all the problems with very good balance of mind, and never comes with a problem, but always with solutions. Musada ma'am.
Gracious sir, with this, it's nice to receive awards, whether it's a lifetime achievement or something as simple as someone coming up to you and saying, nice work. Once again, we'd like to congratulate everyone who has received awards. So can everyone just clap once for all of them?
So with this, we near the end of today's formal program. However, we'd like to remind you of the events which are scheduled in the later part of the day.
There will be a talk by Dr. Rama Shivaram on gender awareness at 2:30 p.m. and something new, a cultural meet at 4:30. And we'd like to invite all of you to attend these events.
We now call upon Professor Ambika to propose the vote of thanks.
Chief guest of the day, Professor Shivaram, Dr. Rama Shivaram, all invited guests from Tirupati, our Director Professor Ganesh, my dear colleagues, friends and dear students. We are about to conclude the formal events related to the celebration of the 4th Foundation Day of the Institute. It's my pleasant duty today to propose the vote of thanks for this function. We are honored to have as chief guest today Padma Shri Dr. Shivaram, Honorable Professor and IISER Senior Scientist at IISER Pune. Sir, we all could feel in your lecture the enthusiasm and the passion with which you have pursued your research throughout. Even though the title of the talk said 50 years of chemistry, you narrated 200 years of chemistry to all of us. On behalf of the Institute, on behalf of everyone assembled here, I extend to you, sir, our sincere thanks for visiting us and presenting the 4th Foundation Day lecture of our institute. We are happy to have Dr. Rama Shivaram with us. As announced, she will be delivering a talk in the afternoon. Thanks to you, Dr. Rama, for coming over and being part of this function. I thank all our guests for accepting our invitation on a very short notice and coming over to participate in this function. And I am happy to note that in the last few days, many of us were involved in making arrangements for this event today, starting from our Director, Professor Ganesh, members of COSA, administration staff, especially academic section, and many of my colleagues. I thank each one of you for your time and sincere efforts in coordinating this event. Special thanks to the IT section and housekeeping staff for the whole arrangements for the day. I would like to place on record our appreciation for FOVIA, the Photography Club of our institute, for producing a very nice documentary. These are things in the beginning, so a big round of applause for that. My congratulations and best wishes to all prize winners and recipients of the 4th Foundation Day Awards. Thank you, Yukta and Athena, for your announcements. Well done. Very big thanks to each one of you for your presence and participation on our Foundation Day celebrations. Thank you.
Thank you, ma'am. With this, we would like to formally finish this, conclude this session. But wait, the fun is about to begin. I wish you all have a nice day. Thank you.